Evaluate each trigonometric sum or difference. In Part A, evaluate the sine of pi over 3 plus pi over 4. Before we begin this question, let's take a moment to learn about sum and difference identities. We'll begin by stating the sum and difference identities for sine. The sum formula for sine is sine of a plus b equals sine a cos b plus cos a sine b. The difference formula for sine is sine of a minus b equals sine a cos b minus cos a sine b. We can combine these to get sine of a plus or minus b equals sine a cos b plus or minus cos a sine b. The plus minus symbol on both the left side and the right side means perform the same operation on both sides. Let's create a box to store this formula. Now we'll state the sum and difference identities for cosine. The sum formula for cosine is cos of a plus b equals cos a cos b minus sine a sine b. The difference formula for cosine is cos of a minus b equals cos a cos b plus sine a sine b. The combined formula for cosine is cos of a plus or minus b equals cos a cos b minus or plus sine a sine b. The plus minus symbol on the left side and the minus plus symbol on the right side means perform opposite operations on both sides. Store the identity. Now we'll state the sum and difference identities for tangent. The sum formula for tangent is tan of a plus b equals tan a plus tan b over 1 minus tan a tan b. The difference formula for tangent is tan of a minus b equals tan a minus tan b over 1 plus tan a tan b. The combined formula for tangent is tan of a plus or minus b equals tan a plus or minus tan b over 1 minus or plus tan a tan b. Perform the same operation in the numerator and the opposite operation in the denominator. Store the identity. Now we'll evaluate the expression sine of pi over 3 plus pi over 4. Use the sine sum formula. Expand using the sum formula. Find the exact values of each trigonometric ratio. Simplify. Add the fractions to get root 6 plus root 2 over 4. We have now found the exact value of sine of 7 pi over 12. In Part B, evaluate the sine of pi over 2 minus pi over 6. Bring up the sum and difference identities. Use the difference formula for sine. Plug in the angles. Find the exact values of each trigonometric ratio. Simplify to get root 3 over 2. We have now found the exact value of sine of pi over 3. In part C, evaluate the cosine of 45 degrees minus 60 degrees. Bring up the sum and difference identities. Use the difference formula for cosine. Plug in the angles. Find the exact values of each trigonometric ratio. Multiply the fractions in each term. Add the fractions. We have now found the exact value of cos negative 15 degrees. In part D, evaluate the cosine of pi over 3 plus pi over 6. Bring up the sum and difference identities. Use the sum formula for cosine. Plug in the angles. Find the exact values of each trigonometric ratio. Multiply the fractions in each term. Subtract to get 0. We have now found the exact value of cos pi over 2. In part E, evaluate tan of pi over 4 plus pi over 3. Bring up the sum and difference identities. Use the sum formula for tangent. Plug in the angles. Find the exact values of each trigonometric ratio. Simplify. Multiply by the conjugate of the denominator. Expand. Collect like terms. Reduce to get negative root 3 minus 2. We have now found the exact value of tan 7 pi over 12. In part F, evaluate tan of pi over 6 minus pi over 3. Bring up the sum and difference identities. Use the difference formula for tangent. Plug in the angles. Find the exact values of each trigonometric ratio. In the denominator, cancel the root 3's. In the numerator, get a common denominator of root 3. Simplify. Subtract the terms in the numerator. Multiply the numerator by the reciprocal of the denominator. Cancel to get negative 1 over root 3. Rationalize the denominator. Multiply the fractions to get negative root 3 over 3. We have now found the exact value of tan of negative pi over 3, or equivalently, tan of 5 pi over 3 if we use the principal angle.